Hi, thank you for tuning in to this last part of time, speed, and distance. So, in this video, we are going to look into two topics boats and streams and races. Beginning with boats and streams, now here I am going to share a very interesting trick. Whenever you face questions of this topic, always imagine a waterfall in your head to better understand and not get confused between downstream and upstream. So, water flowing downwards is downstream, upwards is upstream. Makes it easy for us to remember these formulas. Downstream speed is object plus water, upstream speed is object minus water. Now, these are not the relative speeds, they are the actual speeds experienced when the object flows downstream or upstream. Now, let's look at this first question. If speed of boat in still water is 4.5 and speed of stream is 2.5, find the total time required by the boat to travel 28 kilometers downstream and 12 kilometers upstream. Now we know that time taken is calculated as distance upon speed. So using this formula for downstream, it will be calculated as 28 upon 7. Upstream would be 12 upon 2. So your total time is 10 hours. Next question. A boat covers 18 kilometers one way in a stream in 4 hours and back in 12 hours. So here we are going to apply a bit of logic. We know that downstream speed is more than upstream speed. So we can conclude that time taken to travel downstream would be lesser than the time taken to travel upstream for the same distance. So here I can conclude 4 hours is downstream direction and 12 hours is upstream direction. Now the question becomes very simple. Speed of downstream is 18 upon 4. Speed of upstream is 18 upon 12. Solving this further, you will get the individual speed of boat and water. Moving ahead, a man can row to a place which is 80 kilometers distant and back in 9 hours. He realizes that he can row 5 kilometers with the stream in the same time as 4 kilometers against the stream. Now, with the stream is downstream, against the stream is upstream. Now, as we have compared distance here in the same time, we have learnt in our first video that when time is constant, speed is directly proportional to distance. So here I can conclude that downstream speed and upstream speed will also be in the ratio 5:4. Now if I consider them as 5x and 4x respectively, I can frame this equation for the total time taken. 80 upon 5x plus 80 upon 4x is 9. Solving this, I'll get the value of 4 and thus the value of downstream speed and upstream speed. If I again solve this further simultaneously, I will get the individual speed of water. Moving ahead to the next concept for today, which is races. Now in races, we are going to discuss two types, linear races and circular races. So beginning with linear races, when you see questions of linear races, you will frequently come across two terms. First is head start. What do I mean by this term? So when I say A gives B a head start of 10 meters, it actually means that A allows B to start 10 meters ahead of the starting line, which means speed of A must be such that time taken by A to cover 100 meters would be equal to time taken by B to cover 90 meters. Next, dead heat. So when I say A and B finish in a dead heat, it actually means that they both finish exactly at the same time. Thus, there is no winner, no loser. Now, let's see the different types of questions in this area. The first one. A can give B a head start of 12 meters or 3 seconds in a kilometer race. Now, if I observe this statement carefully, it means that A whether gives B 12 meters or 3 seconds doesn't make a difference, which means for B 12 meters or 3 seconds is same. Now I can use this data to calculate the speed of B, which is 12 upon 3 gives you 4 meters per second. Now because I have the speed, to cover a kilometer, B will be taking 250 seconds. And as I know, A can give B a head start of 3 seconds, which means A must be taking 3 seconds lesser. That gives you 247 seconds. Next question. A and B, they run a kilometer race and A wins by 60 seconds. A and C, another race, and A wins by 375 meters. And for B and C, B wins by 30 seconds. Now here I have 3, A, B and C. So let's try to compare all of these 3 values. If I have to compare the time taken by each, from the first statement we can say that if A takes t seconds, B will be taking t plus 60. From the third statement we can say if B takes t plus 60, C would be taking t plus 90. Now if I just have to compare A and C, we can say that C takes 90 seconds more than A. And from the second statement, it is very clear that C also takes 375 meters more than A. So from this data becomes very similar to the one in the previous question. So I can use it to calculate the speed of C, which is 375 upon 90. Using this, time taken by C would be calculated as 1000 upon speed, which gives you 240 seconds. We know B takes 30 seconds less, which is going to give you 210 seconds or 3.5 minutes. Moving ahead, a very important type of a question. In a 10 kilometers race, A beats B by 1 kilometer. Another 10 kilometers race, B beats C by 1 kilometer. And if A and C, they run a 10 kilometers race, A will beat C by how many meters? You can try it yourself, pause the video and then check the solution. Now if I have to compare these multiple races, let's see the first race. When A covers 10, B must be covering 9 kilometers. For the second race, when B covers 10, C must be covering 9. Now if I have to compare both of these, I'll have to get that common element of B same, for which I'm going to multiply my first data by 10 and second data by 9. So now I get the data over here that when A covers 100 kilometers, B covers 90 kilometers and C covers 81 kilometers. Now let's compare A and C directly. When A covers 100, C covers 81. So for a 10 kilometers race, I can say that when A covers 10, C must be covering 8.1 kilometer, which means A will beat C by 190 meters. Let's move ahead with the second type of races, which is circular races. So for this, I'm going to give you a basic set of data to understand. I'm taking a circular track of 100 kilometers with two objects A and B. Speed of A 15 kilometers per hour traveling in the clockwise direction. Speed of B 10 kilometers per hour traveling in the anti-clockwise direction. Now here we are going to look at the most important types of questions that are asked in circular races. Type 1. When will A and B meet anywhere on the track for the first time? Now as we see, track is of 100 kilometers and A and B, they are moving in the opposite direction. So when both of them are starting at the same time, they both are trying to complete and meet somewhere. So it is similar to a relative speed with opposite direction. So same way I'm going to calculate my total distance as 100. Speed applied is 15 plus 10, so time taken is 4 hours. Let's say they would be moving in the same direction, then your speed would have been 15 minus 10. Moving to the next type. When will A and B meet at the starting point for the same time? Now, to meet at the starting point, both have to complete the complete rounds together. Now for A to complete the whole round, A will be taking 100 upon 15 hours. B will be taking 100 upon 10 hours. Now for both of them to be there at together, we have to know the common multiple of this. So we'll have to calculate LCM of both these times, which is going to give you 20 hours. So at 20th hour, both of them will be at the starting point together. Now in this type of question, directions of A and B will not matter. Whether they are traveling in the opposite direction or the same direction, the answer and the solution to this will be same. Type 3. What are the total number of distinct meeting points for A and B on the track? Now to calculate this, always make sure that you take the speeds of A and B here as 15 and 10 and reduce them to the least fraction possible. So here when I reduce them, the least fraction possible is 3 is to 2. Now because they are moving in the opposite direction, the total number of distinct meeting points, the number of points on the track where they can meet and in any round is 3 plus 2, which is 5. Let's say they were moving in the same direction, then the total number of distinct meeting points would have been 3 minus 2, which is 1. And this includes the starting point as well. Moving ahead with one nice question of races. A hare and a turtle, they decided to race each other, the race beginning at an oak tree and finishing at a pine tree. The turtle's speed was only half of that of hare. So note this. However, the hare got caught cheating and was forced to hop back to the oak tree and start again after it had already covered two-thirds of the distance. The turtle, slow and steady but honest, it won the race by 8 minutes. So how long did the hare take to complete the race? Now this looks like a complex question, but it's very simple if we try to represent it nicely. So let's see this diagram. Starting from oak to pine, we first see that let's say hare has already covered two-thirds of the distance. So I've divided the total distance in 3 parts. Hare is already at two-thirds of the distance. We know speed of turtle is half. So turtle must be at one-third of the distance at that time. Now hare is caught cheating, so hare goes back to the oak tree, and in the same time that hare took to cover these two-thirds again, turtle must have moved ahead by one-third. So this will be the final position of hare and turtle at this point. Now hare again starts from the starting point and turtle starts over here. So finally, when turtle reaches the pine tree, covering the remaining one-third of the distance, as hare's speed is double, hare will cover two-thirds of the distance in that much time. So this will be the final position of hare and turtle when turtle completes the race. I hope this is clear. Now let's understand this in terms of the distance covered. Assuming the length of the race to be 3x. Now if I just consider hare in my head, let's see the total distance that hare has to travel. 2 times here, 2 times back, and then 3 times to complete. So 7x is the total distance, whereas turtle has to complete 3x. Now we know that speed of hare is double than speed of turtle. So by the time turtle will complete 3x, hare would definitely complete 6x, which means hare had x more to complete when turtle had finished the race. Thus to complete this x, hare needs 8 minutes. So to complete the whole 7x, hare would have taken 56 minutes to complete the whole race. So I hope this is an easy explanation for you guys. In case you think you were confused somewhere, you have some query or you want to learn more about this topic, this is where you can reach out to me on. If you have liked this video, please do not forget to share it ahead and subscribe to the channel to keep on getting updates. Thank you so much.